Okay, so in the previous two lectures we went back and we took a look at video 2i, and so now we're going to go back and we're going to take a look at video 3h, which is the football pass, and we had a lot of calculations on that, so I'm just going to go through the results. I'm just going to, here's the sheet, and I'm just going to go through some of the results. Okay, so we figured out that basically the ball took this parabolic arc, and that's not really a good parabola, but it's the best I can muster right now, and it went 26 meters. And what we did is we set up two charts for the horizontal and the vertical. And let's see, that was 26 meters, and it was in the air for 2.6 seconds. So we said that its initial velocity was 10 meters per second, and its horizontal acceleration was 0 meters per second squared. And then we said that it traveled a vertical distance of 0 meters in 2.6 seconds, and it had an acceleration of negative 9.81 meters per second squared. So that meant that it had initial velocity of 12.8 meters per second squared. I'm sorry, just meters per second. And then we threw that into a triangle, and we said that the launch angle was 52 degrees. I'm sorry, we started with this. We started with those two values. We used tangent, and tangent we found the 52 degrees, and by Pythagorean theorem we came up with 16.2 meters per second. Now let's look at this from a energy standpoint. Okay, so when it's here, its gravitational potential energy, we're going to call that 0 meters per, we're going to call that 0 joules, because it's basically, it's at shoulder height, it's going to end at shoulder height, and so rather than saying that 0 is the field and then figuring out how far up a human being you are, we're just going to say that basically shoulder height was where it was launched, and so that's 0 meters, and so the gravitational potential energy at that point was 0 joules. And so the kinetic energy was going to be 1/2, and I apologize, I actually don't know what the mass of a ball is, and I suppose I could just redo the video after I figure it out, but ultimately it doesn't really matter what the mass actually is. So let's come up with something plausible. Tennis ball was 55 grams. Let's say it's, I don't know, 6 or 7 times heavier than a tennis ball, maybe. Let's call it, let's 7. Let's call it 0.4 kilograms. That's about right, maybe. You can go find one and see how close I am. And the velocity is that right there, 16.2 meters per second. So my kinetic energy is 0.5 times 0.4 times 16.2 squared is 52.5 joules. Now, how about at the top? How about at the top, right there? Well, In the previous example, the ball was going straight up in the air and coming straight back down. So there was no velocity at the top. But now we do have a velocity at the top because it's still moving sideways. So it still has kinetic energy at the top. Which way is it moving at the top? At the top it's moving horizontally. What's its horizontal velocity? Its horizontal velocity is 10 meters per second. So we're going to say GPE, we're going to come back to in a second. My kinetic energy, this is something I forgot to do just a second ago. Always write out the equation first. 1/2, 0.4 kilograms, 10 meters per second squared. I can do this one in my head. 10 squared is 100. Times 0.4 is going to be 40, divided by 2 is going to be 20, so that kinetic energy is going to be 20 joules. So that means that the total energy of the whole system is 52.5 joules. The kinetic energy at this point is 20 joules, and so the gravitational potential energy has got to be 32.5 joules. Now I can throw that into there, and I can say that GPE equals mgh, and so my h is going to be GPE divided by mg, so it's going to be 32.5 joules divided by 0.4 kilograms divided by 9.81 meters per second squared. 32.5 divided by 0.4 divided by 9.81. It's going to be 8.3 meters. So I'm going to say that that thing had a maximum height above the person's throwing arm of 8.3 meters. Now, let's just keep going with this. I want to figure out X, T, VI, VF, A. If I throw something up at an initial speed of 12.8 meters per second, so this is a vertical, when it gets to the top it is going 0 meters per second in the vertical direction, and it's going to be negative 9.81 meters per second squared, and I want to solve for that. So I'm going to get VF squared is equal to VI squared plus 2AX. So I'm going to get, if I rearrange that, I'm going to have X equals negative VI squared divided by 2A. My X should be negative 12.8 meters per second squared. The negative comes out front. 2 times negative 9.81 meters per second squared. So here I've got those negatives are going to cancel. I have 12.8 squared divided by 2 divided by 9.81, and I get 8.3, well, rounding but approximately 8.3 meters. So once again, different methods hang together and give the same result, which is what we are looking for. So we can think about it using the equations from chapter 2. We can also think about things from the standpoint of energy, and at this point in time I imagine you guys are going to be more familiar with using the methods of chapter 2. But believe me, once you get further on in your physics careers, energy is what really makes all the sense in the world.